Hello and welcome to another episode of IT Pro TV. I'm your host Mike Roderick, and with me today is Mr. Sean Oriano. How you doing, Sean?
I am doing pretty good. How you doing?
I'm doing fantastic. We got another exciting episode coming your way here at IT Pro TV. We're continuing on with our Kali Linux series, and in particular we're talking about sniffers. So if you missed the previous episode, make sure you go back and check that one out. We got our intro to sniffers, and we've already gone over a few different types of sniffers. There's so many though, and they're so fun to use. Now if they give us a lot of good information, we're going to continue on taking a look at different sniffers, as well as talking about some of the caveats or some of the things that we got to worry about with sniffers in our modern network. So Sean, let's get back into sniffers though. I know we took a look at a couple, like we looked at Wireshark, we looked at EtherApe, which was a nice kind of a protocol analyzer. Didn't really show us the raw packets, but it showed us who we were connecting to and what protocols we were being used. We also saw DriftNet that grabbed all the images that were flowing by on the network. So a couple cool ones there. What else do you want to take a look at?
Okay, we do have some other ones, in the bag here. The one I really think needs to be brought up is what they call DSniff. And DSniff just isn't one thing, by the way. It's more than one. It accomplishes a good number of tasks. Now, we did previously talk about DSniff, in a previous segment, but now we kind of want to flesh that out a bit more because it does so much more than be used just as an exploitation tool. It is designed to be a sniffer, and it does that quite well. It's just the fact that when we talked about it previously, we were using it to gain information that could be used to gain access to someone's account. So what we want to do is we want to look at the whole thing. What DSniff is, like I said, a suite of tools. DSniff is just one tool as part of that bundle. The other tools do just a bunch of different things. Some of the stuff we will look at later on, but we do want to start talking and bringing this into your thought process. What we have is, we have the first one in here, which is DSniff. DSniff, it's simple. You just go through and do -I and tell it what interface to listen on, and boom, it's listening. Okay, now nothing's showing up. I know it's like what's going on in there. Well, what it's waiting for is if I was to now open up a browser, open up an FTP client, I could just start typing in my username and password and connect to it. If DSniff is running and it's running, as you can clearly see here, it picks up that FTP traffic. It will now look at that traffic and say, filter out everything, the data transfer, everything. All I want to display back on screen is a server address you're connecting to and the username and password.
Nice.
That's all it will show you. It will let the other stuff just do whatever. And so it will do that with a multitude of different protocols. Some really kind of ones that you're probably not going to encounter nowadays. Other ones, you definitely are. If you're passing passwords over HTTP, which you can, it will pick those up. Obviously, FTP it will do. The mail protocols it will pick up. All you have to do for stuff like SMTP and IMAP and POP, all those guys, is just hit send and receive on your client. And wherever the credentials are being passed, it will pick them up and display them on screen. Tell you this is the server you went to, this is your account and username, and done.
Nice. Now, is it showing it's not breaking the password? So if it's encrypted or hashed, it's just going to show you that hash value.
Well, if it's hash or anything like that, it's just going to say it doesn't. It's just not going to display anything. If the whole thing is encrypted using SSL or something, then it's not even going to be able to see it at all.
Gotcha.
So it is a very useful thing. And interestingly enough, you turn this on, and I'm not telling you guys you got a blank check to go try this, but if you were to start DSniff on your own corporate network and turn on, just let it sit out there, you might be amazed at just how much stuff you can see that you shouldn't be seeing as easily. So just something to think about. Now, can you get this stuff through other sniffers like Wireshark? Well, yeah, of course you could. You can get all those things through Wireshark. It's just that for Wireshark, you're going to have to set up your filters, and you're going to have to start opening up packets to look for that information. Here, it's right visible to you. All you really have to do if you want to take this to the next level is just do a little greater than sign and pipe it out to a text file and
Nice.
and just start harvesting. That's it.
All right, so focused on authentication type traffic, grabbing all that, and you'd be amazed at how many web applications, websites don't bother to set up, some type of encryption on that authentication process. And if they don't, you'll capture that information pretty quickly.
Yeah, absolutely. They just don't take the basic precautions. You will see people not configure their mail clients to use any encryption, and so they hit send and receive, and all of a sudden, pop, 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 it comes up. It's like saying, that question of going to something like Starbucks and turning on DriftNet. Turn that on. You'd probably be surprised at how much stuff you would catch.
I can't tell you how many networks I've gone to where they've got their email server set up and too many problems. Assigning a certificate to the email server, getting all the clients to trust that certificate, that's too much work for them, right? So they just turn off they just say, all right, we'll just do unsecured authentication, no problem.
Yeah, it's in the clear.
Yeah, you tell your users, it's going to warn you, just click OK, it'll be all right. And maybe that is in-house, right? Because you think, oh, it's all inside, everything's good. What if I've already compromised the system on your network? And now I'm on that system and I'm running something like this, like DSNF. I'm going to see all of that. So as a penetration tester / attacker, those plain text authentications, those are great things.
Yeah, you got to really be aware of those things and what the problems they can actually cause, because they're not uncommon to do, because they figure enable all this stuff or disable things to make it easier for them to administer instead of doing the homework to figure out why they're having that problem and how to make it more secure at the same time, make it so it's working the right way.
Exactly.
But so that was actually just DSNF. DSNF does have other things in its whole suite of tools. Some other stuff we can point out is one called URL Snarf, and that one same type of deal. You just go out, type your URL Snarf -I each-0 in my case, and boom, it's listening, and you can see it tells me the ports it's listening on. Great, happy about that. Nothing being displayed though. So what I'm going to do is, again, open up my browser and just I open it up and I switch over here and let me close that window just so it's less confusing for me to switch amongst. Okay, nothing showed up, but let's see why that happened. I just opened up this browser window over here. Well, look what it's doing. It's looking at the local drive. So I haven't generated anything off the system, so I definitely need to do that. So if I was to go and type something like a news site again and do this and go over to this, well, look at what's happening. The stuff is actually scrolling by. That's the conversation going back and forth between my system and the USA Today website. So you can see just a lot of things, happening there.
Wow.
So yeah, I'm not touching anything. That's all stuff that's being loaded as it pieces together that page.
Yeah, it's loading up the web page, all the different banner ads and graphics that it's got to go grab. So it's connecting to multiple servers and getting all that info, and you're seeing all of it come right back into that little window. Nice.
Yeah. So that's just kind of gives you an idea of what one of the other tools in that suite does. And just to give you a kind of an idea, and let me just control C that to stop it. I can do other deals with that suite of tools, and just to kind of make it easy, me switching through all the things in the DSNF suite. What I've got here is, and maybe you can zoom that up a bit for you. These are the members of the DSNF suite. I still have at least one more I'm gonna show you on there, but you can see these things, the things that it can do. You got ARP spoof. What does it do? It can it spoofs ARP packets. Okay, fine. DNS. It can respond to. It can help you reply to DNS queries. DSNF. We can see what DSNF does. File Snarf to reconstruct files. We've got MacOff, which we'll talk about. Mail Snarf. That one's an interesting one. Look at what Mail Snarf does. Saves email messages sniffed from SMTP and POP traffic.
Wow.
If you haven't encrypted that, it will literally take your emails and display them on screen, or if you want, just pipe it out to a file, and you've got someone's emails that they're sending out and receiving. So you've got that. Then you have message snarf for doing instant messaging. TCP kill and TCP nice are for slowing down and killing connections. If you wanna sever a connection, could be used for doing man-in-the-middle attacks. Like they have two tools at the bottom that are used specifically for doing man-in-the-middle. And then of course you got your URL snarf, which I showed you, and web spy. Web spy is kind of another interesting one, because what it does is if you have that turned on and configured the right way, what will happen is you can have someone else browsing stuff in their system. It means if Mike was over here, I could set it up, if Mike was browsing something in his web browser with web spy set up and the application of ARP spoof, anything he browsed would actually show up on my system.
Wait, not yet.
It would make an identical copy.
So just kind of mirror that connection. You're going to see exactly as I'm going through different web pages and things like that.
Yeah.
It's like you're sitting back and your web browser is just changing as I change it on my machine.
Yeah. Anything you browse to would show up in there. It's just a case of me using forged ARP requests and poisoning the ARP cache on his machine. So it starts changing the flow of traffic, so it's including mine on that, and I'm seeing identical copies of what's going on in his browser.
Nice.
So it's it's a fascinating thing to actually see.
It's probably updated to do more than just Netscape.
Yeah, that's a fascinating one right there. To your local Netscape browser.
Yeah.
If you got that, then you probably shouldn't be in this class.
That's still my favorite browser.
But any case, that's the DSNF suite. Been around for quite a long time, and it's still extremely useful. It's basically a collection, for the most part, a collection of sniffers that are highly customized for a specific purpose. So we really got to like that. But so that's a DSNF, and that's kind of what that suite does. But there are other things that we want to concern ourselves with when we are doing sniffing. So we've seen all these sniffers so far. We've seen, like I said, Wireshark, EtherApe, and there's other ones sitting out there that can do various things. We know if we go into Kaylee and look at our sniffing and spoofing, we can see our network sniffers in there. There's a bunch of ones in there. I mean, look, there's one for SSL that can sniff traffic based on that. So some really neat stuff in there. And then we got our web sniffers, and it just goes on. We've got some good stuff in there. But what if you have a situation where you just can't turn on a sniffer to see all the traffic that you want to see? That's going to happen. You're going to have situations where you try to turn on your sniffer, and the stuff that you want to see is it's there, but it's on the other side of a switch.
All right.
So they've ripped out those switches like we talked about. It's on the other side of a switch, so we can't just go in and get it. We have to do something about that switch, and so we've got tools that are going to come into play. Remember, the way a switch works is a switch keeps track of traffic and where it's going to go by looking at the MAC addresses. And it keeps track of those by having what they call content addressable memory inside the switch. And so it starts keeping track of MAC addresses that are coming through, and so it knows where things are, and it can get into the right spot. Now, if that memory gets filled up, the switch can start having problems. Now, in the old days, if you started filling up that piece of memory too fast or put too much in there, the switch would actually fail open. It would fail right open.
Hub, basically.
Yeah, it would turn into a hub. It would fail out into a hub, which now is great for you as an attacker because you can see everything. We know all the stuff we've seen here can be done without any effort whatsoever on a hub. Okay, so that's all well and good. what if what if if it doesn't do that? Modern switches, most of them tend to fail the other way, where if you beat on it enough, you'll fill up that memory and it fails close until it gets reset, or it can deal with what it has on hand. So, thinking about this, how do we cause a situation where we can cause that switch to fail? Well, the way we can do that is we can fill up that cam table. Okay? Now, we have, of course, tools that can do that. One of the tools that we have to do that is as part of that DSniff suite. And what we have is you can type in a tool here called Mac Off. So we go ahead and we type that in. And I'm only going to let this run for a second. If you're going to run it, I would recommend you let it run for a second. What I do here is I hit enter on it, and you can see it's just blasting stuff by. It's generating random MAC addresses. If I keep letting this go, it has the capability to generate hundreds of thousands of them. Every like I think it's like every minute or something. It could do like 130, 150,000 MAC addresses. Every minute. So it's gonna crush in short order. It's gonna crush a switch in there with the amount of traffic it's getting. So this would be a good way to kind of just to throttle that switch, so you can start getting around it if it will fail like that.
Right. Yeah, and that's something we got to find out, I guess, and there's really only one way to find out. Because remember, we get it, you compromise a machine, you get onto that machine, but the problem is that machine's hooked up to the corporate network or whatever, and it's connected to a switch. And as Sean said, and we've learned in Network Plus, that's a point-to-point connection between you and the switch, and all you're going to see, that switch is only allowing traffic that's destined for that node that's out that port. So the idea is a tool like MacOff, flood it with MAC addresses. It can't keep track of who's out what's port, and hopefully fails open, and now it's like a hub, and I can capture all the traffic that's going by, because now all traffic goes out every port. There's a problem we have. Modern networks, I mean, nobody buys hubs anymore. Switches are comparable or in price to a hub, and you get so much more functionality, and we depend on that to make those contention domains in our Ethernet networks, that you're going to have a tool like this under your belt.
It's definitely not the only one that does it either. There are other tools that do this sort of thing that will just blast stuff at a switch with the intention of seeing if they can just crush it with the sheer amount of traffic that's being fired at it. And like I said, some will fail into an open state as a hub. Some will fail to a closed state, and then they have to be reset either manually, or they automatically will do that after a period of time. So either way, if you look at it, either way, you're going to do something to that person. You're going to be able to capture traffic, or if it fails the other way, you've just caused a mini denial of service, because you've just blocked traffic by causing that thing to lock itself down.
And not just that port, right? All ports are going to be on that. All the other people that are connected to that switch are no longer going to have access either. Now, you set off some flags or some alarms, hopefully, on the network. I mean, not hopefully for us, but hopefully for the network. You're like, hey, the switch is down. People are going to be calling, but maybe that's what you're trying to do. So, good tool to have in the belt. And as you said, there's others that'll let me do that same kind of thing. Just try to flood that switch with so much info that it can't keep up, and hopefully it fails open and says, I give up. I don't know who's out what port. I'm just going to send all the traffic. Now I can sniff all that traffic, just like I was hooked up to a hub. Or it fails closed, and then we don't get anything. But we did do a denial of service on the network, so good to have.
Yeah, so you can definitely cause people some problems doing something like this. So keep that in mind if you're gonna do something. If you're going to do something like this, what the consequences of that would be. I'd also remember when you blast that many MAC addresses out using something like MAC off, someone's going to see it. Right. An IDS is going to see that. I just ran that really quickly, on this network here, so I didn't destroy anything or cause any problems. All of
a sudden our video locks up and we were no longer broadcasting live. Yeah, Sean was just running MAC off.
It'd be funny if you had that streamy kind of blurry video. It gets worse. Like, what's going on? So, but you'd have to keep an eye on what you're doing with something like MacOff. If you blast enough of that out, yeah, it's gonna have some effect. An IDS is gonna pick it up, and once it picks it up, it's alerting somebody presumably, and then that person's gonna investigate and see, yeah, well, that's somebody messing around, and it's gonna track down what that problem is or do something to block you out.
And that's one of those things you're going to have to learn, right, Sean? They'll say we do compromise the system. We're doing our pen test. We've compromised the system on the inside. We're starting to run a sniffer on that system. Well, how do I know if I'm on a switched Ethernet or not? I mean, 99% of the time in today's networks you're going to be, but how do I know for sure? Well, if you start capturing traffic and the only unicast traffic you see is destined for the machine that you've compromised, right? You should know the IP address of the machine you've compromised. And if you're looking at that captured traffic and the only unicast traffic is coming to that machine, then you're pretty good chance you're on a switched Ethernet, right? If you saw other destination addresses, unicast, now you got to ignore the broadcast and things like that, then you can assume maybe that you're on a hub or a portion of the network that's hub. So one of the ways you might be able to tell you're on a switched Ethernet is just looking at the traffic and seeing what you see at all.
Yeah, exactly. It's pretty much common sense once you know how a switch works in a hub when all those guys work. You're right. If you were to turn on a sniffer and the only traffic you see is coming to you or leaving you, that's highly unusual. If you're not in your home network, that's highly unusual. Mm-hmm. So that indicates more than likely that there's a switch out there someplace that you and everyone else is plugged into. So that's switch's fingerprints all over it.
All right, well, Sean, again, a lot of good information on sniffers and how we can use them to capture information, and how there's these suites that have multiple tools built into them that allow me to really focus my efforts and capture just certain types of traffic if that's what I want to do. We also saw how in today's networks we're going to see a lot of switched Ethernet, and how we can get around that. You're not stuck just because you're on a switched Ethernet. There are ways that I can force it to show me traffic that's going to other nodes on the network. Hopefully, using something like MacOff, or maybe it fails closed and then we don't get to see anything, but nobody else on the network does either. So maybe that's a plus to it. But anything else we want to throw in here before we wrap this one up?
I would say you're probably at this point, a lot of you might be thinking, well, I still got Wireshark, I'll stick with that. Now is not the time for you to get like a product loyalty here and say I'm going to stick with Wireshark no matter what. Wireshark is a fine piece of software, but if you just want to stick with only Wireshark, you're going to miss some of these other really neat pieces of software that have unique perspectives and unique capabilities that Wireshark either cannot emulate or it would take a lot of work to emulate it. So don't get so tied to Wireshark that you're just not willing to try it. I've seen and heard people that way, like, oh, I know Wireshark, it's the best one out there and all that. Well, saying it's the best one out there, that's a subjective thing. But it's not subjective to say that there are a big wide family of specialized sniffers that also work with Wireshark that could offer you something that's just much better than Wireshark being able to do without a lot of work. I mean, look at a DNS sniff. Look how easy it would be to capture credentials. You do the same thing with Wireshark. Wireshark's going to take longer to do it to stage that attack. With something like DSniff, I can do that with a few button clicks or a few taps on the keyboard, so to speak. I've got that information.
Nice. All right, so lots of choices. Don't be stuck with one. Try them all. You might find that you like one of those others better than Wireshark, or at least it's a good complement to whatever else you've got in your tool bag. All right, well, I'll tell you what, ladies and gentlemen, that's going to end this particular episode. We hope you guys enjoyed watching. I know we enjoyed making it for you, but for now, signing off for IT Pro TV, I'm Mike Roderick.
And I'm Sean Ariano.
And we'll see you next time.